Eva. Welcome to Only 5 Minutes.
Hello, Emiliano. Thanks for having me.
Eva, you are the scientific coordinator of the Viperlab initiative, which is a European project that aims to join together all organizations working on perovskite solar. What results the project has achieved to date?
That we launched the project in summer of 2021, and we've now built up all the infrastructure in order to facilitate a connected and a coordinated access to many of the leading European research facilities that are working in highlight perovskite photovoltaics research.
One of the main goals of the project is building a huge database.
It's a database in the sense that we're collecting all the information of infrastructure that is being made available by the 15 partners of the Viperlab project. But in addition to that, we also have a strong ambition and a strong focus on collecting and making research data available that is being generated as part of research around the world, actually, on halide perovskite photovoltaics.
And is this database immediately available to the scientific community?
It's already available, and what already had been in place right when Viperlab started is a quite extensive literature database that we assembled in 2019, and that was launched last year. And where basically information can be found of results that have been disseminated in the scientific literature in the domain of halide perovskite photovoltaics research. But the infrastructure we've built, so with Viperlab, we're now consecutively expanding this to become an infrastructure that's also collecting experimental data that scientists can make available, meaning we also gonna enable making research data accessible that currently is not actually necessarily being disseminated in the peer-reviewed scientific literature.
So we could define Viperlab as a big directory for everything happening around perovskite solar.
Really, or the goal is really to make every single experiment, every single experimental outcome, to make that kind of accessible according to fair data principles. So first of all, it has to be findable, it has to be accessible, interoperable, and then also reusable. And that's kind of a challenge that I think is also inhibiting progress in research, and especially in the industrial development of photovoltaics technology, that a lot of the research findings are actually never actually being made available, especially the things that don't work are not being reported. So that leads to assume that there's a lot of experiments, a lot of tests that are kind of being repeated because they are never fully documented. And the documentation is also actually not being made available to the research community, but neither to the public. And that is something very fundamental that we need to change in order to accelerate the further development and also the deployment of emerging technologies.
Is the project also seeking to bring all this scientific data and results to the industry?
So in Viperlab, I mean, one of the major components of Viperlab is that we are making research infrastructure accessible to academics, but also the industrial community. So there's 15 partners around Europe with many of the leading research institutes that offer research infrastructure for early stage manufacturing and prototyping of new and emerging PV technology, but as well infrastructure that allow for standardized validation, efficiency testing, and also stability testing. And by this coordinated approach, we actually also want to make infrastructure that not every single research lab has available. For instance, in scaling small area test devices to larger area, we want to make that accessible. So you can essentially write a proposal on based on lab experiments you might have done before, where all you might now need in order to bring it to the next level, to a higher technology readiness level, might now specifically be the ability to scale your prototypes to larger areas, or to do stability testing, long-term stability testing under different standardized conditions, which is something that not necessarily every research group that is active in the fields has available by themselves.
Could all these sources of information help make projections on the efficiency or stability of perovskite solar?
And in this Viperlab project, we're not only tackling halide perovskites as a single junction solar cell technology, but we're also tackling hybrid tandem photovoltaics. So integrating hybrid perovskite materials, for instance, also with existing other PV technologies such as silicon, CIGS, or a second layer of a perovskite.
In your opinion, are the industry and the scientific community doing enough to improve perovskite cell stability?
So the stability is really set. I mean, we've already established that one of the major opportunities is actually using halide perovskites as an add-on technology to boost the performance of mass-produced PV technologies such as silicon. But that also means we have to match the stability and the operational lifetime of silicon as a technology. So that means we have to guarantee operational lifetimes of, I would claim, 25 years at least. Now, the question is really, with halide perovskite, what's really surprising is the material that doesn't necessarily exhibit a lot of intrinsic high stability, but instead it's actually material that exhibits a high degree of dynamic properties that also lead to effects that cause self-healing. So this is maybe one of the first times where we are investigating a PV material that doesn't necessarily perform well because of being non-breakable, but because of actually having a number of properties that enable it to dynamically heal defects generated in itself. So that also means the performance can actually dynamically improve over time. And what has been observed and also established is that when operating perovskite solar cells under standard outdoor conditions, so day-night changes in illumination, that the operational lifetime is substantially longer than keeping the solar cells under constant illumination. And that has been one of the interesting questions also, where the network is thinking about how to standardize testing protocols for a solar cell technology that actually does recover during dark cycles. And when it does, can have a substantially longer projected operational lifetime than if it's being tested under standard constant illumination conditions. And it's really, in the end, these kind of factors that make it currently quite challenging, but also interesting to establish what would be viable and reliable measurement routines in order to predict the long-term operational lifetime of this technology correctly, and not basically end up doing tests that lead to degradation because they don't allow the system to self-regenerate and self-heal.
My time is up. Thank you for 5 minutes, Eva.
Thank you very much, Emiliano.